we have a question that's asking about the frequency density, and it's about histograms. So first of all, we have this histogram about the frequency density and the weight of watermelons, and it's asking us to work out the total number of the watermelons in the field. So when we look at this problem, it's asking us the frequency, right? But in the histogram that we're given, we only know the frequency density and the class. So we need to use the frequency density formula in order to calculate the frequency which the problem is asking us. So we're going to recall the frequency density formula. So frequency density, FD, is equal to frequency divided by class, right? Which means, in this case, in order to calculate frequency, we need to multiply the frequency density by class. So we're going to calculate the frequency for each of the bars as you see in this histogram. So I'm going to call the first section right here, I'm going to call that A, second section B, C, D, and E. In the actual solution, you cannot do this. You need to actually write out the class in order to be more clear. But in this case, I'm just going to explain it, how to do it. So I'm just going to be concise and write it in alphabet, okay? So first of all, we notice that the class right here is 1, while this one is 0.5. And this one again is 1 and 1 and 1.5, okay? And then we're going to get the frequency density, which in this part is 15. And it's going to be 32. And this is 23. And this is 30. And lastly, this one is 12. So now we're going to calculate the frequency for each of these bars in the histogram you see. So first of all, we have A, which is calculated by 15 times 1, which is equal to 15 watermelons. And then B is 32 times 0.5, which is equal to 16. And C is equal to 23 times 1, which is 23. And D is 30 times 1, which is 30. And E, lastly, we have 12 times 1.5, which is going to be 18. So now we have all of the watermelons in each category that we call class, okay? And now we're going to calculate the total number of watermelons in the field, which is achieved by adding these all up. So A plus B plus C plus D plus E is going to be 15 plus 16 plus 23 plus 30 plus 18. And what do we get? 102 if you plug it into the calculator. And so our answer is going to be 102 watermelons. Okay? So the key point of this problem was to identify that the histogram was only telling us the frequency density and the class, and we needed to calculate the frequency using this formula, which was frequency equals to frequency density times class, in order to get total number of watermelons in the field, which was about frequency.